This exercise illustrates to find mass of solid if molarity is given. Question says how many gram of Na2SO4 are required to make 0.35 liter of 0.5 m Na2SO4. So what is given? Volume of Na2SO4 is given. So this is 0.35 liter, and molarity of Na2SO4 is also given. And this is equals to 0.5 m. And now question says calculate the mass of Na2SO4. So we have to calculate mass of Na2SO4. Now what should be the plan for this problem? How I will proceed? I know the volume, I know the molarity. We can basically from molarity and volume we can find moles of Na2SO4. So we can find moles of Na2SO4. And once I know the moles of Na2SO4, if I multiply by molecular mass of Na2SO4, then we can calculate mass of Na2SO4. So let us say I have, if you remember the formula, molarity is equals to moles by volume, and this time volume is in liter. I can write moles is equals to molarity times volume, and volume we have to take in liter. So now in the present case, let us say we have solution, and molarity is 0.5, so moles of H2SO4, and this is equals to molarity times volume. Molarity is 0.5 and volume is 0.35 liter, so this multiplied by 0.35. And now once I know the moles of H2SO4, this is basically Na2SO4, not H2SO4. Now we can calculate molecular weight of Na2SO4. This is sodium is 23, so 23 into 2 plus sulfur is 32, and we have 4 oxygen, so 4 into 16. So let us say this is 46 plus 32 plus 64. So this is 142 gram per mole. So now I know the molecular weight, so we can calculate weight of Na2SO4, and this is moles times molecular weight, 0.5 into 0.35. This is the moles, and this multiplied by 142 gram per mole. So this value is 0.5 into 0.35, this multiplied by 142. So this is 24.85 gram. So this much weight of Na2CO4 required to prepare 0.35 liter of 0.5 m Na2SO4. So weight of Na2SO4 required is 24.85 grams. So weight of Na2SO4 required this is equals to 24.85 gram. Now let us do this exercise. Concept is same, moles is molarity times volume. Now let us say part A. How many gram of Na2SO4 are there in 15 ml 0.5 m Na2SO4? So volume is given. So volume is 15 ml. So that is 15 into 10 per minus 3 liter. and molarity is also given. Molarity is 0.5 m. So if I know molarity and volume, we can calculate moles of Na2SO4. So this is molarity times volume. Molarity is 0.5 and volume is 15 into 10 to the power minus 3. So this is the moles. Now we can calculate weight of Na2SO4. This is equals to moles time molecular weight 0.5 into, and molecular weight we have already written. So if you see on the top, molecular weight is 142 gram, 142 gram per mole. So this multiplied by 142. So from here we can calculate. So this is 0.5 times 15 times 142, and this all divided by 1000. So this is 1.065 gram. So this is around 1.065 gram. If I round, this is approximately 1.1 gram. Now let us say the next part. How many milliliter of 0.5 m Na2SO4 solution are needed to prepare 0.38038 mole of this salt? So I have molarity is given, mole is given. I have to calculate volume. So molarity is 0.5 m, 0.5 m. So this is molarity is given, and moles is 0.038. So moles of Na2SO4, this is equals to 0.038 moles. So 0.038 moles. Now we have to calculate volume. So we already said moles is equals to molarity, and this multiplied by volume. Now in this case, moles is given 0.038, molarity is 0.5, and we have to calculate volume. Let us say volume is V. So from here we can write V is equals to 0.038 divided by 0.5. So this is 0.076 liter. Now we can convert into milliliter. So volume is 76 milliliter. That is this multiplied by 1000. So I need 76 ml of Na2SO4 0.5 m solution, so that we can have 0.038 mole of this salt. If you see all the above calculation, we are using only one formula. Moles is equals to molarity times volume. So that is number of moles is equals to molarity into volume. And from here we can have three kind of calculation. That is molarity is equals to molarity is equals to mole by volume, or volume is equals to mole by molarity. So from the one equation we can have three kind of different equation that can be derived, and then we have to find, sometime we have to find mole, sometime we have to find molarity, sometime we have to find volume. If molarity is volume is given in this case, we have to find moles. Moles and volume is given, molarity we have to find. Moles and molarity is given, we have to find volume.